work done in a solid object along a frictionless horizontal surface is equal to the change in the object's what? So keep in mind, and we did a lot of this when we were doing the collision unit, we have change in kinetic energy is the same as the change in work. So the work that's done, remember, is based on the motion that is based on the impact that occurred from the change, which is either also your force times your distance. So answer is kinetic energy. Question number 2 is asking you to look at the graph based on work versus time. So if we're looking at work over time, that's the equivalent of force times distance divided by time. Which means that's the amount of work that you put in over a given amount of time, which is the same thing as power. And so that is number 4. Okay, number 3. A student does 60 joules of work pushing a 3 kilogram box up the full length of a ramp 5 meters long. What is the magnitude of the force applied to the box to do this work? So we have work done, which is 60 joules. We have the mass, which is 3 kilograms. We have the distance, which is 5 meters. And we have the force, which is our unknown. So we know that work equals force times distance is what we're looking for. Then we want to know what was applied to the box. So the amount of work done on the box is 60 joules, which is equal to the force times the distance that it traveled, which was 5 meters. So 60 divided by 5 give you your force, which is 12 newtons. Okay, so make sure that you look at the equations and you're looking at what you need. You may not need everything. Alright, we're going to do question number 5. A motor used 120 watts of power to raise 50 Newton objects in 5 seconds. we can break up work into force times distance, so I can change my equation to power equals force times distance divided by time, which equals, now, the problem is, when we look at the equation, we don't have any force. But I know that force is also equal to the weight of the object, which is going to be mass times gravity. So you need to make sure that you understand that weight is the force of an object, and whatever that object's weight is has to be equivalent to the amount of work that you put in to move it. Otherwise, it can never be moved. So that's Newton's third law that goes into why work and weight is equal to that force. So mass times gravity, we do have that. So we have mass. First, we're going to plug in our mass, which is the 400 kilograms. So this is now m and g. Times gravity, which is going to be our 9.8 meters per second squared, times the distance, which is 10 meters. And we're going to divide that by time, which is 8 seconds. And you should get 4,900 watts. So please make sure that you understand how these equations are used. If I don't have force, then I can use the weight equation to find the force given in the y direction, which is your m times g. Okay. Lots of stuff to remember. Alright, 22. Which quantity is a measure of the rate at which work is done? And so that should just be power. So remember, it is a rate of how fast you get some amount of work done. We're going to go to question 30. How much work is required to lift a 10 Newton weight from 4 meters to 40 meters from the surface of the Earth? Wait, no, I skipped this one. I'm sorry, we're going to do question 31. So, student A lifts 50 Newton blocks from the floor to a height of 0.4 meters in 2 seconds. Student B lifts a 40 Newton box from the floor to a height of 0.5 meters in 1 second. Compared to student A, student B does. So we're going to look at the work, and we're going to also look at the power that's produced. So if I have student A, I'm looking at the work, which was 50 newtons, times the distance, which was 0.4 meters. And that means that I have, 20 joules of work. Student B is 40 Newton force times 0.5 meters, and that means I have 20 joules of work. So that means that their work is equal to each other. Now if I look at the power, though, which is the amount of time it takes to get that done, I'm just going to divide it by the time that it took to get their work done. So for student A it was 2 seconds, for student B it was 1 second, which means this has 10 watts of power and B has 20 watts of power. So that means B has more power. So equal work, but B has more power. So that means that your answer choice should have been number 1. Okay, the next one is number 34. Okay, question number 34. We have the box to the right, varying horizontal force. What is the relationship between the applied force and the distance of the box moves? So really, if I look at the graph, I just need to figure out the area underneath each of these graphs. And then I just add them together. So I'll figure out the one here, which is our rectangle. So we'll just do length times width. And then here we'll just find the area of a triangle. And I'll just add these two together, and I can figure out the total amount of work done. So you're going to do length times width for the box. So 6 times 3. And that's going to give us 18 joules. Then for the triangle, we're going to do 1/2 base times height. So that's 1/2, and our base is 3 times our height, which is 6. And that should give you 9. So 18